So now it's time to find the difference quotient. This is extremely important for calc when you're going to have to find limits. You're going to have to know how to do this. So the difference quotient formula is there's 3 or 4 separate pieces that you have to know. So the main ones, if you look at the formula, is you have to separately find f of x plus h. What does that mean? You're going to substitute x plus h into the function, right? So in that spot, and then you're going to simplify it. So let's do that step first. So maybe just to stay organized, I like to do it piece by piece. So on the side, right, that first piece is we need to know what f of x plus h is. So again, we're going to be substituting x plus h in the x spot, right? We're making that substitution. So it should look like that. So after you make the substitution, now you have to simplify. Now, please don't say that's x squared plus h squared. That's not what that says. That is the same thing, right? Anything squared means you're multiplying the base times itself 2 times. So actually you should be distributing. Now, does it matter whether you multiply those guys first, right? Or if you want to multiply these two first? No, because of the commutative property. Very popular thing is people like to distribute the later two. So I'm just going to copy down that 2. Okay, so now we're distributing or foiling, whatever way you want to do it. So x times x is x squared. X times h, I could just write it as xh. Now, h times x is, I can write it as hx, right? But isn't it also the same thing as xh, right? Because of the commutative property. And that's exactly what you're looking to do when you do these problems, because if you notice now, they're like terms, okay? And then h times h is going to be h squared. And now we're going to distribute the 2 to everybody, right? Oh, actually, no. Well, you can, but as I said before, how about we combine these like terms just to work with smaller terms? So what's 1xh plus another xh? Now we have 2 xh's, right? And then it's time we can distribute the 2 to everybody. So we have 2x squared, 2 times 2, so that's going to be 4xh, and then plus 2h squared. None of these 3 terms are like terms, so that's it. So f of x plus h is equal to those 3, that polynomial, I should say. Should I define it as a polynomial? I should just say those 3 terms. Okay, so what I'm going to do now is, because we know what f of x plus h finally equals, now it's time in the formula, I'm going to make that substitution in that spot. Okay, so I'm going to, let's see, just copy down the difference quotient, right? So separately, we're going to, right? So f of x plus h minus f of x all over h. Okay, so f of x plus h, as I said, we are going to substitute in there because we just found out that's what was equal to. So we got 2x squared plus 4xh plus 2h squared, right? So this was the substitution that we made. Now we're going to, so then the next part of the formula is, now we want to, trying to find a different color here. Now we're trying to subtract it by f of x. Do we know what f of x is equal to? Yes, that is equal to 2x squared. So I am going to substitute that. So minus, right, 2x squared all over h. Okay, so we made those substitutions. Do I need those parentheses? Definitely never, we never care about, we don't ever need that first set of parentheses, right? Only the second set of parentheses, because you're technically multiplying by -1, right? So that sign will end up being different. So that's 2x squared. I'm just copying down those first 3 terms. And now the only thing that will change is the sign of the f of x. So it will be minus 2x squared all over h, okay? Next, you're gonna, after you finish the stage, you made your substitutions and you simplified. Now you're going to look to see, are there any like terms that we can simplify? And pretty much almost always, terms are going to be canceling out if you did this right? So notice that the positive 2x squared and the minus 2x squared, they cancel out, okay? So then we end up with 4xh plus 2h squared all over h, okay? So after terms should be canceling out, the step after that is you should always then factor using the GCF method, okay? So notice both terms are divisible by 2, and they also have at least one h. So the GCF is 2h, right? And so whenever we substitute using the GCF method, the GCF comes outside the parentheses, right? So how many terms are there? There's 2 terms. So there should be 2 things in there, right? So 2h times what gives me 4xh, 2x. And then 2h times what gives me 2h squared. I just need a positive h. So notice now what happens is you should end up getting the h's to cancel. And so our answer is going to be left with 2 times the quantity of 2x plus h. Now, you technically, I kind of have a feeling that some teachers are going to be like, well, you didn't really need to take out this 2 here. The important thing is you really should have just taken out the h. I would honestly say, looking back after doing this, you should really just take out the h and not the 2. And the reason why, I mean, this is correct. The reason why we don't really care about the numerical part of the GCF is because technically we're going to actually just distribute that 2 back. So that final answer should just be 4x plus 2h, okay? So this is really the more simplified version. Okay, so technically speaking, as I'll just repeat, the numerical value of the GCF, you don't have to pull that out, but definitely the h you'll have to, because those will end up canceling out. I hope you found this video really helpful, and I want you to make sure that you check the description. I left links to also my online course if you're interested. I have chapter modules and quizzes and homeworks and step-by-step answer keys, and I have video lessons of those. So again, I left that link in the description. Make sure to like and subscribe, and make sure that you also leave a comment so that if you want to also request any future videos, I'd be more than happy to make those. So I hope to see you soon.